Okay, we're connected up to a Bitx 28 kit low-pass filter. We're putting signal into the antenna terminal, and I'm picking it off right on the bottom side of C50 between Q21 and C50. So this is just the low-pass filter itself. We're sweeping from 1 meg to 50 meg. So once again we can measure the cutoff over here. Let's look at the insertion loss first. We're down to 1 dB per division. So it appears we have less than 1 dB of insertion loss anyway. We can measure the 3 dB point, which is going to be down here. So we go to manual, we sweep across to the 3 dB down point, and I'm measuring 17.93 megahertz. If we bring it back up to the corner, it's starting to roll off right about here, and that's 15.34 meg, and up here should be our, I can get it set, frequency dial's touchy. Anyway, that looks pretty good. So let's go to the next step. If we do a full sweep, that's sweeping to 110 megahertz. Somewhere out here around 65 meg or so, we do have a little blip. Come back to there, and we see that we increase I have a loose bezel. I have about 10, 20, 30, 40 dB or so of rejection. Actually, if we were to look at where we want to look would be the third harmonic, because with a push-pull amplifier, the second harmonic is pretty much attenuated. So let's go out to the third harmonic, which that would be about 42 megahertz, 43 megahertz. We'll sweep out there with the manual mode. That's 42.4 megahertz right at that point. So somewhere around the 8th division is what we'll be looking at. Go back. So we'll take and measure that. 10, 20, 30, about 35 dB of rejection for the third harmonic. I just moved my pickup point for signal down to where I've gone through the bandpass filter. I'm actually hooked on D2 button hook, and we're running a symmetrical sweep. The center right here is 14,260, and we're running 3 megahertz across the complete screen. So each division works about 300 kilohertz. So now let's take and tweak the two bandpass filter capacitors, C14 and C18, just to show you what it does. We'll take C18 first, because that's the one I looked at first. So we can broaden it out, but I'm losing amplitude as I do that. So this peak right about there, we'll tweak on the other one. We should be able to see it do about the same thing. So if I wanted to, I could lose a little more signal and flatten this thing out a little more. And you notice I'm shifting the frequency of the center frequency as I do it. See, I raised the center frequency, 14,270 or so. come back and adjust it kind of to a peak. I'm going to peak it there right on the center radical mark. Let's narrow the sweep down a little bit. We'll go to 1 meg. So I've got 1 meg across the whole screen. So this is about 200K here. It's fairly flat. So that's not too bad. So that's the bandpass filter. Let's go ahead and look to see if we can look at the crystal filter. Here's our test setup. Here's our input to the board. And we're taking the output on this side. So it's real simple to do. Just one thing we have to avoid though is we can't change frequencies. So we can't run through the mixer and make measurements through the mixer. It has to be all the same frequency. Okay, we're hooked at D11 button hook, R64's button hook, and we're running a symmetrical sweep of 10 kilohertz for the full screen. So each division worth of kilohertz. You can see on this particular filter, I'm probably about 3.5, almost, well, actually about 2.5 to 3 kilohertz wide. I'm going to adjust it over there a little bit more. But it's got a little bump. Could be that I might be able to tune that filter and make it look a little better. I have another Bitx kit board here, so let's hook it up and see what it looks like. This is the second one. It definitely looks different. Got a peak and a dip in the middle, and it also is about 3 kilohertz wide. So, like I said, with this system we could tweak it, but I'm happy just to be able to measure it and look at it. So you've seen the filter networks in both Bitx version 3 and the Bitx 28 kit. Hopefully you've learned a little bit. Even if you don't have the equipment, at least what you've been able to see is what actually things look like internal to the receiver.